All right, welcome here to the first in a series of water and wastewater videos. And we're going to be focusing on the math part of water and wastewater, and specifically the metric system and how it is used in those various different fields. Just to get going, remember that the metric system is based on the 10 or 1,000 or million system, and it really is just moving the decimal place back and forth. So let's start off with the units for volume. We're looking at either liters or cubic meters, and please remember there's 1,000 liters in a cubic meter, and then there's 1,000 cubic meters in a megaliter, or 1,000,000 liters, 1,000 times 1,000. So that's our first foundational concept. 1, 1,000, 1,000,000. Next one is mass. And again, mass starts off with a very, very small quantity, a milligram. And there's 1,000 milligrams to a gram. And then 1,000 grams to a kilogram, or 1,000 times 1,000 gets you 1,000,000 milligrams to a kilogram. Time in the metric system has a number of options, either as seconds, or there's 60 seconds to a minute. So if you have 2 minutes, it's 2 times 60. Or there is 60 minutes to an hour, or 60 seconds per minute times 60 minutes per hour gives you 3,600 seconds in an hour. And then typically the days, your options are 1 day or 24 hours, or 24 hours times 60 gives you 1,440 minutes per day, or you can have 24 hours in a day times 60 minutes per hour times 60 seconds per minute gives you 86,400 seconds in a day. So those are kind of like our starting points that we're going to be looking at all throughout the rest of these video series. Concentration can also be used in the water industry, especially, for example, in dosing chemicals. For example, like a dosage of 4 milligrams per liter of, for example, chlorine when you're doing disinfection. So chlorine concentration, or any concentration, could be in milligrams per liter or grams per cubic meter. Very common one. They don't measure out milligrams in big water plants. They typically measure out in kilograms per megaliter, or really small quantities could be in parts per million. Other options for concentration, especially if you have a bit of a chemistry background, you have the molarities and the normalities, or grains of hardness, for example. All of these are different ways of measuring how much solute, the disinfectant, per volume of solvent, in this case water. So let's take a look at some of these really, really simple cheats that I have found to be helpful, especially if some people have a difficult time making this conversion between liters and megaliters and cubic meters. All right, let's start off with just a reminder. To go from 1 megaliter to cubic meters, you multiply by 1,000. To go from 1 cubic meter to a liter, you multiply by 1,000. Or to go from megaliters to liters, you do 1,000 times 1,000. So that's again our starting part. But a lot of people, especially if they're not that familiar with it, or they kind of get lost with all the decimal places moving to the right or to the left, here's a simple little cheat. Make 3 columns. Megaliters is in the left-hand column, cubic meters is in the center, and liters is in the right-hand column. Then let's just say that you have 3.5 megaliters, and you want to do a conversion. How many cubic meters is that? So notice you put the megaliters, 3.5, in the left-hand column, and you want to go to the middle column, which is cubic meters, and notice how you're going from left to right. So whatever direction you're going to go, that's where the decimal moves, and you move it 3 spots. So that works out to 3,500. And if you'll notice there, you change the decimal in 3.5 to a comma, and it turns it into 3,500 cubic meters. Well, if you want to go one column further, another 3 decimal places, and it works out to 3,500,000 liters. Well, if that works from left to right, let's go from the middle column, 825 cubic meters, and you want to go to the right-hand column. So if you're going to the right, the decimal place also has to go to the right, and it ends up being 825,000 liters. Notice you understand a decimal to be after, in the middle column, after the 825. You change that 825 decimal into 825 comma, and then add 3 zeros. So that's just a simple little cheat. If you want to go to the left, then you're going to the left, so you move the decimal to the left, and it turns into 0.825 megaliters. Well, if you have a very, very large number of liters, 12 million, and you want to go again to the left, so you move the decimal place to the left. So now instead of the decimal turning into a comma, now the comma turns into a decimal. So it's 12,100. And if you want to go one column further, move the decimal place again 3 spots, and it becomes 12.1 megaliters. So that's the kind of like the foundational thing. You got to know in all of our subsequent math-related problems, when you're going from a liter to a megaliter or to a cubic meter or a gram to a kilogram to a milligram, you have to be able to do these basic conversions. So let's do a little bit of a cheat now. So 475 cubic meters, how many liters would that be? Well, move the decimal to the right, 3 spots, 475,000. Now, if you have 2,450,000 liters, now you're going 2 columns over, or 6 decimal places. That works out to be 2.45 megaliters. Or if you have 7.1 megaliters, and you just want to go 1 column over to the right, move the decimal 3 spots to the right, and you have 7,100 cubic meters. So let's see if you can do these without the columns. Now you have to visualize these. So you tell me, if you have 6.24 megaliters, how many cubic meters is that? Well, that would, remember, we're in the left-hand column, you're going to the middle, to the right, so that would be 6,240 cubic meters. 475 cubic meters, you're in the center column, and megaliters is to the left, so you move the decimal place to the left, and that works out to be 0.475. Now I've walked you through the first 2. Let's see how you can do with the next 2. 1,370,000 liters equals 1.370 megaliters. 28.6 cubic meters is 28,600 liters. 5.13 megaliters equals, how many liters would that be? 5,130,000. 340,000 liters equals 340 cubic meters. Now, if that works for volume, let's see what happens now for mass. 2.85 kilograms. You want to change that to grams. 2,850. And again, moving it to another column. Move the decimal 3 more spots. 2,850,000 milligrams. So again, hopefully you're picking up on that concept of whichever column you're in, that's the direction that you want to go will determine what direction the decimal place goes. 713 grams going to the left, 0.713 kilograms. Going to the right, 713,000 milligrams. 16,400,000 milligrams. If you go one column over to the left, that's 3 decimal places, 16,400 grams. Go another 3 columns, or another 3 decimal places, sorry. That's 16.4 kilograms. So let's see what you can do here. 112 grams, how many milligrams will that be? 112,000. 452,300,000 milligrams. Now you're going 2 columns over, or 6 decimal places. 452.3 kilograms. 18.3 kilograms is 18,300 grams. Summary. So now we're at the end, summarizing this little video, and a couple of things you have to remember. Whenever you're doing these conversions from megaliters to cubic meters to liters, remember, where are you starting? Which column are you in? Where do you want to go? And that'll determine how many decimal places you have to go and in what direction you have to go. So those are just absolutely foundational principles. Well, are you going to go to the right? Are you going to the left? And then above all, does it make sense? 1 milligram is a really, really small amount. So if you have 1 kilogram is a big quantity, you're going to need a whole bunch of those small little quantities to equal that quantity out, or to equal the mass out. So if that works for volumes, same things with masses. What column are you in? Where do you want to go? And that'll tell you what direction and how many decimal places you're going to be moving, to the right, to the left, and then how far. I hope this video has worked out for you as a good starting point for your journey into the metric system and how it applies to the water and into the wastewater industry. Take a look at some of the other videos that are in this channel or will be added in the near future. Good luck with you in your upcoming water and wastewater challenges.